Hi, for this recording, we will investigate whether the function f of x equal to x for x less than 1 and x squared if x greater than or equal to 1 is differentiable at the point x equal to 1. If so, we will compute f prime of 1, the derivative at the point 1. To do this, we must recall the definition of derivative. In this case, let's look at the slide here. We have a slide on one-sided derivative. The derivative on the left of a point C is f of c plus h minus f of c divided by h, where h goes to 0 minus, means h less than 0. And derivative on the right, c is equal to f of c plus h minus fc over h, where h is more than 0 now, h goes to 0 plus. Then the function is differentiable at the point C if the derivative on the left and the derivative on the right exist and both equal. And in that case, we say the derivative at the point C is this value, common limit. Okay, let's look at the solution for this question now. So I'm going to set up a quotient. So first of all, what we're going to do is check whether the limit of this thing exists or not. That means that we're going to look at this limit of x of h goes to 0 of f of 1 plus h minus f of 1 over h. Now the reason we use 1 here because our point of interest is x equal to 1. Right? Our point of interest is x equal to 1. This is the point C here. Alright, so you look at the slide, the C is 1. Okay, so now let's find out what is this thing. Now this limit, in order to compute, we have to compute separately for h goes to 0 and positive and h goes to 0 and negative. So let's consider this one first. Consider the limit of h goes to 0 plus. That means h is positive now. So we know that if h is positive, let me write some comment here. Since h positive here, so that means that 1 plus h will be more than 1. So we also know that f of x is equal to x squared for x more than 1. Alright, so we have this for x more than or equal to 1, f of x equal to x squared. So f of 1 plus h now is 1 by h squared. And f of 1 is x here. F of 1 is kind of formula. You can see that f of 1 is 1 squared. Right? F of 1 is also 1 squared. It's 1. So you can put this into our calculation. This is equal to limit of h goes to 0 plus f of 1 plus h is 1 plus h squared. F of 1 is 1 over h. Now to find the limit, let me expand this out first. This 1 plus 2h plus h squared minus 1 over h. And this will give me, after cancellation, we know that 1 and minus 1 cancel. So let's leave us h2 plus h over h. Since h is not equal to 0, so this can cancel, get 2 plus h. When h goes to 0, 2 by h goes to 2. So this is what we call the limit from the right. Let me write this. F r prime 1. The derivative from the right. Now let's look at the derivative on the left. Okay, so let's consider another one. Consider f prime l at the point 1. This is the limit of h goes to 0 minus f of 1 plus h minus f of 1 over h. This is called the different quotient, and we're going to take the limit of h goes to 0 minus. Since h less than 0 now, so 1 plus h will be less than 1. So as f of x is equal to x for x less than 1, so f of 1 plus h will be 1 plus h. We also know earlier f1 is 1. Also fx equal to f1 is 1 earlier. So you can make use of this information to find out what is this. This is equal to limit of h goes to 0 minus 1 plus h minus 1 over h, and 1 and minus 1, they cancel each other. So this is h over h, and limit of h over h is 1. Is 1. So the limit from the left, the derivative from the left is 1. So we compare now as the derivative from the left is not equal to the derivative from the right at the point 1. So fx is not differentiable at 1. Okay, at x equal to 1. So this conclude the solution. So you don't need to find f prime 1 doesn't exist. That's the end of this recording.